Alright, in this little video here, we're going to be talking about exponents one more time. A couple of more difficult problems, but not really so much more difficult as you're just doing the same things over and over and over. So, if you've watched a few of my videos by now, you know that I don't really care for negative exponents. But the question sometimes comes in as to when do I play with them? And my general rule is if you play with them and it makes the problem harder, then wait. This is one of those cases. If I were to flip this -2 to the bottom, so this x to the -2, it doesn't go down here because of this outside exponent. It would actually look like this. And then this would be squared, and then we have another fraction down here. Well, that doesn't really look nice. Now I have a fraction within a fraction that also has another fraction in it, and I'm probably going to get confused. So I'm sure that some of the more mature viewers, the ones that have been through math for a while, will recognize that, oh, well, you have 2's on the outside. You can just combine them under 1, 2. You can. I'm not going to do it here. That's somewhat more advanced than what most people are looking for. So what I would recommend in this case is, because I have exponents that are happening in the top and the bottom separately, or the numerator and denominator, I am going to go ahead and I'm going to utilize our power to a power rule. So if I take an exponent, something that has an exponent, and I raise that whole mess to another exponent, the effect is that I multiply the exponents. And so I'm simply going to take, and I can mark each one of these. If it doesn't have an exponent, just give it a 1. That way I'm keeping track. And I always draw these lines just to make sure that I'm distributing to everything. So the top gets distributed through. That's going to give us 7 squared x to the -4 and y squared. Remember that this is not -2 plus 2, it's -2 times 2. Then down on the denominator here, we've got the square. It's coming through just to the x and the y, giving us x squared and y to the -2. So from here, I can go ahead and I can kind of simplify it, if you will, down to this. At this point, whichever method you tend to use, go ahead and use it. Some people will love the fact that, you know, I can go ahead and take, for example, this piece here. These are, by the way, the rules of multiplying fractions allows me to split this up. Okay, so I have my x to the -4 over x squared. Well, that's the same as x to the -4 minus 2, which is x to the -6, which means I flip it down to the bottom. And that's perfectly fine. There's nothing wrong with that. It's not the method I personally choose, but obviously it gets you the right answer, so why not? The method I normally choose is anything that has a negative exponent, I flip to the bottom so that I don't have a negative exponent. So if I were to do that and rewrite it, I would get 7 squared, which I'll clean up later. I have the y squared that was already here, and I bring another y squared up. And then down at the bottom, I have this x squared that was already there, but then this x to the 4th came down there as well. From here, I just clean it up. I notice that I have effectively 4 y's here, so this is going to give me 7 squared y to the 4th. I have essentially 2 x's here, 4 x's here, for a total of 6 x's. Notice I get that x to the 6th. It's the same thing. That's why you can do this 47 different ways, and it still comes out the same answer. And then finally, just to clean it up, I'm going to go ahead and expand this out, leaving me with 49 y to the 4th over x to the 6th. That is our simplified answer. There are advantages to leaving negative exponents in there, and what come to mind is integrating and differentiating in calculus. I mean, that leaving the negative exponents in there usually makes it a little easier. In fact, largely people will convert from having a fraction to having negative exponents just to make it easier on themselves. So it's just one of those things. All right, let's do another one here. This one's kind of roughly the same idea, except that we're also dealing with negatives on the outside. So again, you can, if you wanted to, just like the last one, you could go ahead and distribute things through. and then flip if you want, or utilize your exponent rules if you wish. I'm stuck on the whole flipping thing, so I would flip these two. Because both the numerator and the denominator have exponents that are negative, I would go ahead and flip-flop the entire thing. And the reason for this is if I'm multiplying through, I've got a negative that I've got to distribute. That means that I have signs that have to change. If there's a way for me to screw a sign up, I'm going to find the way. It's inevitable. It's almost like Murphy and I are like right there. So the negatives on the outside say I'm going to flip each piece. The effect is the entire fraction flips. But each one keeps its respective exponent. It just becomes positive. 3x squared y to the negative 1. Notice the stuff on the inside doesn't change. This is because we haven't messed with the stuff on the inside. The only thing we've activated is this negative exponent on the outside. Normally I get emails for the comments, so if you comment below and you're like, wait a minute, what do you mean? How can you just flip it and that's it and it becomes a positive? There's actually a way to use the rules to show that that must be the case. I'm just not going to do it here. If you would like to see it, just go ahead and leave a comment below and I'll show it to you in a separate video. And then I'll link it in this one. Alright, so now I'm going to follow the exact same method that I did above there. I'm going to take this 3 and I'm going to go ahead and distribute it through. Again, remember, if there's nothing there, it's an assumed 1. At the same time, I'm going to take this 2 and I'm also going to distribute it through. Again, if there's nothing there, it's an assumed 1. This is going to give us 6 cubed x to the negative 3 y cubed over 3 squared x to the 4th. I'm multiplying these, so this is 2 times 2, not 2 plus 2. And then y to the negative 2. And then just for the sake of consistency, I'm going to go ahead and anything that's a negative exponent, I'm going to go ahead and flip that down. Or in the case of this negative 2 on the y, flip it up. That's going to leave us with 6 cubed, and then a y cubed that was already on top, and then the y squared from the bottom. On the bottom, it gives me a 3 squared, this x to the 4th, and I move the y to the negative, or the x to the negative 3 and to the bottom, leaving me with x cubed. Cleaning it up, I'm going to do this in 2 pieces, and I'm going to kind of explain the reason why or how I'm doing this other piece over here. But this is 6 cubed, and this is going to be y to the 5th, and then 3 squared, and x to the 7th. Okay, so now I've got a problem. Well, you can see I don't have a calculator, so I've got this huge number here. I don't know what 6 to the 3rd is, but it's 6 times 36, whatever that happens to be. If you wish to use your calculator to just go ahead and resolve this, you're going to simplify it down. Right off the top of my head, I can't give you an answer. It's 3 times, it's 24. 24 will be on top, but I'll show you how I did it rather than using a calculator. This next piece uses this idea that if you take 2 things and you raise that are multiplying and you raise it to a power, you in a sense distribute that power through. We've been using that idea up here. So it's a to the m, b to the m. Well, that also works in reverse. So I'm looking at this 6 to the 3rd, and in my mind, I'm seeing 2 times 3, all raised to the 3rd power, which is really 2 to the 3rd times 3 to the 3rd. If I do that, now I've got this 3 squared, I really have 2 cubed times 3 cubed over 3 squared. And now I have 3 3's on the top, 2 3's on the bottom, and when I divide them, that leaves me with 1 3 on top. So this is 2 cubed times 3. 2 cubed is 2, 2 times 2 is 4, times 2 is 8, times 3 is 24. And because it's on top, it's 24 y to the 5th all over x to the 7th. And that's our answer. So there's a method to this, and if you recognize how to use all of these different rules in these different ways, they can kind of simplify your life, even though they might look a little complicated as such. Ultimately, if they're numbers, you can go ahead and throw them in your calculator. The TI series of calculators can convert from decimal to fraction, that sort of thing. A lot of scientific calculators can do the exact same thing. If you have a Casio or an HP, of course those can do it too. It's just a matter of the command structure is a little different in each. So they should all reduce automatically, giving you 24 when you go ahead and reduce that. I just didn't happen to know what 216 divided by 9 was. Yeah. But that's it. So I hope this video helped you out. Take care.